What? Hi, Liv. Sorry, I have a mint in my mouth. Okay. Here we go. We just did this do now right here, and we basically identified the inner function, and we called it f of x, and then we identified the outer function, and we called it g of x. For example, the inner function here would be 2x plus 9. He's clearly on the inside of an outer function, x to the fourth. For b, 5 over x would be the outer, 4 minus x would be the inner. X squared minus 5x would be the inner, the square root of x would be the outer. All right, cool. We can do this later if we have time, but I kind of just want to show you guys the rule, work with that, and then you can dig into the conceptualness behind it, right? Okay. Let's skip down to where the chain rule is located in our formula booklet. So 5.6 is the chain rule. And it basically says, if you have an inner function u, and then you put it into an outer function g of u, you take the derivative of the outside, don't touch the inside, then you multiply by the derivative of the inside, okay? It'll make more sense once we do an example, but it's pretty much saying that dy dx is composed of two changes because we have two variables, a y and an x, right? Every incremental change in x will affect y. Every incremental change in y has come from an incremental change in x, right? So if we have a composite function, the inner function is affecting the outer function, of course. So if we find the derivative of the outer function with respect to u, and we find the derivative of the inner function with respect to x, when we multiply those two together, we will be able to find the change in y over the change in x, and we have accounted for the fact that one is inside of the other, okay? So here's what we would do. Let's do it. Huh? Yeah, it's like an investigation, but it'll make more sense once you know the rule, and then you go back and you're like, oh, I see exactly why this works, you know? I used to do it the opposite way, and kids would just be like, what are we doing? And I would be like, do you know yet? And they'd be like, no, and then I'd be like, okay. So I've flipped it now. But here we go. So for part 2, example A, what is the inner function here? Oh my gosh, you guys are so good. So we're going to let u equal the inner function. Okay? Then we're going to find the derivative of u with respect to x. So do you like the way you can keep track of this is like if this was a y, and you found the derivative, it would be dy dx. But since there's a u here, it's going to be du dx. Right? Okay. So I'm going to find the derivative of u with respect to x. So that's just going to be 2x minus 4. Okay. This is the part where it's like a little funky, but it's okay.
This one.
What's up?
Can you write that as like u prime equals 2x minus 4?
No, because when you plug it back into the structure for a chain rule,
Like
you want to be able to keep track of your two parts there. Well, and now the outer function, let's write him in terms of u. What would the outer function in terms of u be? Remember, u represents x squared minus 4x.
U cubed.
Yeah, good job. So now when we find the derivative of this guy, we're going to find the derivative of y with respect to u. Now we want to plug this into the overarching structure where the derivative of y with respect to x comes from the derivative of the inside with respect to x times the derivative of the outside with respect to u. Right? So basically the derivative of the outside times the derivative of the inside. You'll see this come together later on. So now you just put the pieces where they go. So this guy goes here. And this guy goes here. So I now have 2x minus 4 out front. Then I have 3 times u squared. But remember, u is a tool. U is not part of our answer. So what do you think should go in for u here?
Why is u squared?
U, right? What?
Why is u squared?
Because we took his derivative right here. Good question, right?
Oh,
And the 3 was here. I mean, if I was doing this, I would have put the 3 like out front, but okay. So what's going in for you? X squared minus 4x. And then now I'm going to clean it up. So I've got dy dx is equal to 3 times 2x minus 4 times x squared minus 4x squared. Okay. So I want you to use the u's and everything to keep track of your work, but you're going to learn that when you're doing the chain rule, right? You take the derivative of the outside, so you kind of treat it like a power rule, times the derivative of the inside. And do you see how that came out exactly in our answer? Right? Okay, but I want you guys to use u's and y of u and all that good stuff for now. But you'll get there at the end. Right now, the likelihood of making a mistake is very large. So let's make sure that we have the structure right, and then you can start using the, you know what I'm saying, shortcut. That's the word I was looking for. Okay. So what's the inner function for letter B? Yep. And then du dx is 10x. Y in terms of u will be the square root of u. Okay, this is something that I would probably start to memorize, right? So if you have the square root of x, the derivative of the square root of x, right? It's going to be 1 over 2 rad x. And you should just start memorizing this because it comes up a lot. It's going to make your life easier. How would that happen? Right? That's the long way on the right. That's the shortcut on the left. You have the square root all the time, so let's just start memorizing it to make your life easier, okay? So the square root of x would just be 1 over 2 rad x. So dy du in this case would be, try to practice with like the new memorization. It'd be 1 over 2 rad u, right? Rad, you are rad. Yes, you are. So then now I'm going to plug it into my structure. So I now have 1 over 2 radical, I'm not going to put a u, I'm going to put u back in, times the 10x, and then I'm just going to clean it up. Ooh, the 10x is going to reduce, hooray! So I now have 5x over the square root of 5x squared minus 2. And then if you're starting to look for the shortcut, right? Let's go back in and look at the shortcut, right? 5x squared minus 2 all raised to the 1/2 power. I rewrote this to the 1/2 power because I'm going to attempt to use the derivative of the outside times the derivative of the inside, right? So the derivative of the outside would be 1/2 5x squared minus 2 to the negative 1/2 times the derivative of the inside. And then wouldn't you set that up in the exact same structure as you got from before? Yeah. All right, I'm gonna scroll. All right, let's try y. Ooh, What do you guys think for this one,
Is 2 over x like the normal?
Well, let's see. I think a good rule of thumb is to let whatever is under the square root be your inner function. Mm-hmm.
It's like the way I have it written is dy over d times d over dx, but haven't we been writing it the other way?
Oh, I'm sorry. Is that confusing? Did I
Well, no,
invert
I
them
just,
this time?
I just realized it and I just like thought about it a minute and I got confused. But
Multiplication
it
is
can go either
commutative,
way.
and I should do it the same way every time so as not to confuse you.
No, it's
I
fine.
apologize.
I just like looked at it and I'm like, I couldn't figure out which numbers went where.
No, it doesn't, it ultimately does not matter. But, so I'm gonna let my inner function be 1 minus 3x. So du dx will now be negative 3. Y is gonna be 2 over the square root of u. And the reason why I chose this is because I can rewrite the the square root of u in the denominator as a rational power, right? So then I can use the power rule. So that's why I've chosen to make that guy my outer function. Yeah. Okay. So this now becomes
Wait,
2u.
so du over dx represents the inner? Or the
Yes, that is the derivative of the inside.
Okay.
If you want to think about it like that. Yep.
outer? Or du, and
And then
du
dy
over
du is the derivative of the outside. Yep. Good distinction there.
On the test, will we have to write out all of these?
No, once you start breaking away and using the derivative of the outside times the derivative of the inside, that's fine. Just make sure that you're not making mistakes when you do it that way. Okay.
Right here.
I feel like finding the derivative on a test would be like find the derivative, or it would be like find the derivative.
Would it be 2x for the negative first time?
Find the derivative.
But it like asks to find the derivative.
Sorry, there's a lot of people talking. What?
It's okay. But it asks like find the derivative, or like find the derivative using the chain rule. Like you know how like in algebra would be like, oh, do this using the square. Like would it tell you what?
Oh. I don't remember. I'm pretty sure I leave it up to you. Because a lot of times you'll get something that looks like the product rule example, where there was like things that you would need to use the chain rule inside of a product rule. So I think I'm not too explicit in the directions.
Okay.
I think I just like let you do it however it needs to be done, you know?
Yeah.
But then I will look through and let you know though before the test for sure. All right. So now I have negative 2 over 2. So I'm going to have a negative u negative 3 over 2. So let's rewrite that one. It's going to be negative 1 over the square root of u cubed. Okay. If you had to break this one up kind of, you don't have to, but just so we're like getting used to doing this, right? What does the square root of something cubed become? Right? So just, I don't know, looking for the patterns that make our lives easier. I don't know if that necessarily makes our lives easier in this case, but. So now we have dy dx is equal to du dx times dy du. So I now have dy dx is equal to, so I have negative 3 times negative 1 over. I'm going to use the fancy one, u rad u. All right, I'm just going to rewrite this again because I feel like if I did it all at once, I would make a mistake. So I've got negative 3 times negative 1 gives me 3 over. U is 1 minus 3x, square root of 1 minus 3x. Okay. And could you use the same tools that we've been using in the past to check your answer?
Yes.
Yeah. You just graph the original, graph its derivative, graph yours on top, see if it's the same. All right. Do you guys want to practice this one with the derivative of the outside times the derivative of the inside? Yeah? Okay, so first we're going to rewrite it so we can use the power rule. Is the shortcut confusing anyone? Do we want to keep doing it the long way for a couple more minutes? Yeah? Okay. All right. Great. And we'll just keep, that's fine. Totally fine. All right. So on D, what is my inside function? Let u equal x squared, bless you, minus 2 over x. How should you rewrite that so it's a little easier to work with? Yes, perfect. Okay, so then du dx will now be 2x plus 2x to the negative second. I'm going to, again, rewrite that one. This is getting pretty crazy. Okay, plus 2 over x squared. Okay. So that's the derivative of the inside. And then let's find the outside. Y is equal to 2u cubed. Are we good with that? Okay. And then now I have dy du is equal to 6u squared. All right, let's put it all together. dy dx is equal to du dx times dy du. dy dx is equal to, okay, what do I got here? I got 2x plus 2 over x squared times 6. Oh, I don't love that 6 right in the middle there. That's confusing. And then u squared, x squared minus 2 over x squared. All right, let's attempt to clean this up somehow. dy dx. Let's just put the constant out front. And then I think this is as good as it's going to get. Okay. Yeah, I think I should have put the squared first, but that's fine. It doesn't really matter. Okay, so if this is just another method in our toolbox, right? Okay, this is how we take the derivative of compositions of functions. Got it, right? If we wanted to nest this in a broader skill, couldn't we find the equation of the tangent line for something that's a composite function at a specific x? We sure could, right? So now we're like gonna get a little trickier now that we have the skill. Let's do an application problem, okay? So we are going to find the equation of the tangent line of f of x equals the square root of x squared minus 3x when x equals 4. So whenever you have something like this, you set up point, slope, equation, little t-chart, right? For the point, I got to evaluate f of 4. So I got f of 4 is equal to 2. So my point will be 4, 2. So that will be my x1, y1. Then the slope, I'm going to calculate the derivative and evaluate it when x equals 4. So f prime of x. Okay, let's set ourselves up here. So we've got let u equal. What's my inner function here? X squared minus 3x. I love your sweatshirt. Du dx is going to be 2x minus 3. Y will be the square root of u. Ooh, aren't you glad you memorized those? Because now it's so easy. 1 over 2 rad u, right? You're like, yeah, that was 2 minutes ago. What? Okay, so now I've got the derivative of this guy will be du dx times dy du. So I now have f prime of x is equal to, okay, now I've got 2x minus 3, and I know he's going to be multiplied by 1 over 2 rad u, so is it okay if I just kind of combine a few steps here? Are we good? Yeah. All right, now I'm going to evaluate it when x is 4. We already found this over there. Yeah, we found it over here. Okay, so that's going to be 2 times 2 is going to give me a 4 on the bottom. And then 6 minus 3 is going to give me, oh no, 8, 6. 8 minus 3 is going to give me 5. Okay, so that 5/4 is my what? Who's feeling brave and wants to tell me about him? What? He's on his head. Good job. All right, so I got this part. I got this part. Let's not lose the forest through the trees. What's that third column for? We got to find the... Start with point, slope, form of a line. Plug everything in. I've got y minus 2 equals 5. Wait, did it say tangent or normal? Tangent? Okay, just checking. X minus 4. All right. That's a... Wait, hold on. Y minus 2. 5 over 4, x minus 4. Yep, we're good. Okay, so do you guys want to check our stuff on here? Do you know how to check something on here? What do you think? All right, it's the exam. Here you are. what's our first recommendation? What do you guys think? What should I do? Sure. Well, what did you find the derivative for? So you could evaluate it and find the slope of the tangent line, right? Can you think of a faster check? Yes, we could do numerical derivative at a point and just be like, oh, right? Okay. So let's make sure that was correct. What is this? 4? Ha. Oh, it's covering my X. Hold on. Stop. Okay. Oh, hi, you're in the exponent. We love that for you. Hold on. Sorry. Fail. I hate when I do that. Okay, so that's the slope of the tangent line when x equals 4. And if you wanted to just like, you have an extra couple of minutes and you want to make sure that it like makes sense, right? You could always graph the original.
Derivative of that then.
How do you what?
Tab.
Oh,
and then
well,
this, and then
well, you already like kind of know that that's right. But you could just graph the derivative using the lobster button, and then it's d over dx. But like you already checked the numerical derivative at a point, and it's the same as what you got. So like you don't have to check if the derivative is right, you know.
Yeah.
But you, if you're like, oh yeah, you would do. This is a funny looking graph. Okay, and then I want to see if when x equals 4, if that would be like the slope of the tangent line. So let's practice graphing these in relation mode, right? Or you could always just like move the y over and or move the 2 over and do it quick if you think you can do it quick. All right, when x equals 4, does it look like this is the tangent line right there?
yeah.
Yeah, right? Cool. Go you. All right. So let's see. You can go back and do this activity if you want, but if you already kind of understand what's going on, I would say it would be a better use of your time to start your homework and just work through some practice problems, okay? Definitely stop me if you have any questions, all right? Is anyone going through the exploration activity? Because maybe whoever else is, you can do it with a person. No? Okay. I would start my homework too if I got a chance. No shade.
For the homework, should we leave them in like factor form like we just did, or expand them?
Don't expand.
Okay.
Not unless it's a quotient rule and you think things are going to cancel. Do you know what I'm talking about
Yeah.
by that? Yeah.